All right, so this is JavaScript, the new parts. We'll get into some stuff with JavaScript. Before I get into this, how many of you are JavaScript developers? Well, there's a few of you. How about Java developers? All right. How many of you are actual developers? Okay. All right, a good mix. Knowing that the audience here is predominantly Java, I'll bring out a few points in this. I've been a Java developer for a long time, and over the years transitioned into JavaScript because I didn't mind it, and I liked working on the front end. And so I ended up doing that type of work. And over the past couple of years, I've gone exclusively into the front end UI work. So that's me. That's the pic that I use wherever I'm at online. So if you find that, that's me. Twitter handle's at the bottom. Yeah, I am an engineer at Red Hat, and I'm currently the lead UI developer for the Developer Tools and Experience group. So that's what I'm doing for them. Okay, before I get into the content in this, you guys got questions? Raise your hands, ask, let me know, and keep an open discussion. Help you guys not fall asleep after lunch. All right, so we need some context for JavaScript to really grasp where we are and how we got there. So back in '95, Brendan Eich created JavaScript. He wrote it in 10 days. And some people are really harsh on him for that, but they had to get it out. He had some certain timelines, and he'd written languages before, so it wasn't his first rodeo. So he did it in 10 days, and then went through several iterations as time went on. They went through several names, like Mocha was the first name, and eventually they settled on JavaScript because they wanted it to be aligned with Sun Java. They were trying to piggyback off of that. So went through several iterations, and around 2004, they were trying to get out ES4. So the ES is for ECMAScript, and the ECMA is the standards body that adopted it and has owned it since then. But they weren't able to get the agreement amongst all the parties in the board trying to figure out what was going to go into this. And there was a lot of advanced features. So they killed it, and it sat. And so from '99 to 2009, you got 10 years until you get the next release of JavaScript. And the changes in ES5 were minimal. And you access those by using useStrict. I don't know if you've guys seen that in JavaScript before. So then it sat at ES5 for a very long time until a couple years ago when they finally got ES6 out. So the formal name for it is ECMAScript 2015, and we shortcut it to ES6. And then they just finalized in January the ECMAScript 2016, or ES7. But ES7 has only 2 features, and the rest are just bug fixes. So, questions? Good? All right. So to do, we got to learn some ES6. That's what we're focused on here. My goal here is that you guys would pick up some of the reasons why moving to ES6 is better and the advantages of it. So try to make that as simple as I can for y'all. So from here on out, we're just going to stick with code, and we'll go through a bunch of examples. All right, in pre-ES6, if you want to write a string, single quote, double quote, doesn't really matter. So hello world's example for you. Start this off with. Can everybody see this? Even in the back? All right. So to concatenate strings, whether it's in JavaScript or even in Java, it's the same way. You just use the plus sign and you concatenate them. It's fine if you're only doing one or two things, but it gets annoying when it gets bigger. So one of the things that they did is they improved that with a different format. Now this is not a single quote, it's a backtick. That's the key, that's the tilde right above the tab key. And that also allows you to use template strings. So now you can embed it in the dollars and braces, so you can put them right in there like that. So it makes it a lot cleaner to look at. So when things get bigger, when you start to fill in more strings, then you want to have, so this is old school JavaScript. You've got to use the concatenation, and you can see how we're referencing the properties in an object, in an array, and we can make that a lot easier by using the template literals and the strings like this. All right. Sometimes we need to build out a whole set of HTML, and when you're doing that, you got to do a lot of concatenation, a lot of quotes, and we want to keep it structured like this so when you're going to debug it, you can actually see what's going on with it. And we have the /n in there so that it's a new line when it does print out, and you can actually see it and work with that. You can clean this up a little bit by putting a slash on the end of it, but you still got to have that /newline/ in there. And so obviously, you can just put the backticks in there, and it wraps up the whole thing and makes it really nice and neat. Easier to work with, easier to read. All right. One of the newest features, one of the biggest known, well-known features for ES6 is the use or introduction of let and const. All right, so let's look at this code for a second, and you guys tell me what you think this is going to do. So we've got the variable x, it's 3, and we're creating a function. We're going to pass in a Boolean, so make random. Do we want to make this thing random? So we're going to get a number, and then we check if it's random. If that's true, then we're going to go through and run math random on it, and then we can return x. If not, then we just return x. So I'm going to take that method, get number, and I'm going to pass in a false. What's it going to send me? All right, why?
It's false.
Why is it false?
Yeah. If you don't have the variable the name false.
Well, the variable is false. That's fine. But the problem is it's not going to be 3. It's going to be undefined. And here's why. In JavaScript, we have something called hoisting. And so it takes that variable that we have here, which var x equals math, that one, and it takes it and puts it at the top of the function. It's not going to look outside of the function because it was declared inside the function. Variables, or var, is function scoped. So it's inside of that function. And this gets to be really annoying, especially when you're just starting out working with JavaScript and you don't realize what happens here. So when the compiler looks at JavaScript, it's going to take every variable declaration and move it to the top of the function. And it's only the function. There's no other scoping in JavaScript up through ES5. But with ES6, we have the introduction of let, which is block scoped. And block scoped is just something in the curly braces, so just inside of those braces. So now we've got let being described there, and it's within the scope of the if statement. So when we run this, because the let is within the if statement block, it doesn't affect the one that's in the return, so the return has to look higher, and then it goes, well, I don't have anything here, there's no let in here, no var in here, so then it can go higher and it can see the one above it. So that's how let works. Const works exactly the same way, except you can't change it. It's not entirely immutable, though. So if you have a simple thing like pi here, you can't modify it once it's created. However, if you make an object, the reference is not changeable, but the content inside the reference, the content inside the variable, is mutable. So that can be kind of dangerous. If you do want to really lock something down, then you can pass an object into object freeze, and then it's not changeable at all. If any of you are familiar with Java, and this works similar to final in Java, it works the same way. One of the big differences in Java and JavaScript is the use of final versus const here. Final can set the value of that item anywhere in the class, whereas this has to be declared. When you say const, whatever the thing is, you have to declare what it is at that point. So you can't do it later on. So everybody said they're a developer. I'm hoping everybody understands what a for loop is. Standard for loop in Java and JavaScript, same way, both ways. Here we have an array, and we're passing in, we check the array length, and we cycle through that array, and we pull out, for each of the indexes, we pull it out, and we do console log, which prints it to the console. In ES5, they added a for each, which simplifies looping through an array. So you can run this on arrays, but only arrays. And it runs through it, and you can pass in the element and the index and get those out, and you can then pull the same thing. One of the key differences with the for each is that it's going to run through the entire thing, and you can't put a break in it. So if you run through a for loop, three-part for loop, you can put breaks at whatever point and jump out of it, but not with a for each. So it's going to run through the whole thing. The addition in ES6 is the for of. And this allows you to have a cleaner syntax than the standard for, but with the ability to break in it. And it can work on anything that's iterable. So maps and sets, not just arrays. So that's the big difference there. If I go up, you can see this one has the access to the index. Here, I don't have the index in here, but I can add it by doing this. If I go in and set an array for the index and the element of whatever it is, then I can pull that out as well. All right, functions. Now, for Java developers, the way functions work is probably one of the harder things to grok. And some of the changes that have been made so that it fits more like what people expect it to work like. But what we're doing here is more functional based. So this function is, you pass in a function to a map, and then it iterates over that array, and it does the function. And here it's going to take x from the array and x times x and return that. In ES6, we clean it up a bit. We take out the word function and the parentheses and the braces, and you just put that fat arrow in there. And so it's just like that. You can add each of the other pieces in there as needed. Well, not each, but you can put the braces in there. So if you have, as it gets more complex, but you don't want to use the word function. You want to use the word the arrow instead to keep that difference. Now this has a really important difference for us, and that gets into lexical scoping. And for this, we use the word this. Okay, Java developers, what is this reference in an object? Yeah, the object. Right? In JavaScript, it references the calling object. The calling context is what this is a reference to. So here we have this UI component is a button, and the this is for the UI component. And when I want to reference it in the inner function, so this function that you see up here inside of the event listener, I have to use the self. So this is a trick, and this is common across all of JavaScript, that you'll use self or that or underscore this or some variation on this so that you can have a reference to that outer this. So this is how we do that in standard. However, when you go to a fat arrow or the arrow style functions, the lexical scoping is so that you can actually reference the calling one's this instead of the one you're in. So it cleans it up. It makes it a lot simpler, and you don't have to worry about the this. So you can see we added the template literal, but the this is the this for the UI component button, not the one that's the function that we're in. This is the key difference in an arrow function. The syntax is just easier to read, but how it's using the keyword this and how it accesses it is the key. JavaScript tends to think of everything as some type of Boolean. And it uses the terms truthy and falsy to designate that something is one or the other. And depending on how you use it, or where you're accessing things, you can leverage that. This is a common pattern if you are trying to have default variables. So you have this move function, and if you don't pass in the x and the y, well, it'll default to 0. And how it does that is it takes the x and it says, OK, if there's an x, great, that's a truthy thing, so I'll just leave it to whatever you set it to. And if not, well, then there's an or. So truth or false or 0. Well, 0 is true, so I'll just put a 0 in there. It's sort of a hack, but it's the way we do things in JavaScript. And then you can see how we can print that out. Right. But in ES6, you can actually name them and then reference those directly. And you put the value in the parameters section right there. All right, now we're getting into destructuring. And if I want to have a method that returns more than one thing, because methods only ever return one thing, you got to return an object or an array of said things. So in this case, I'm returning an array of two numbers, 1 and 2. And if I want to get those out of the getXY, well, then I got to do getXY. It creates the XY array, and then I can access those with the index 0 and index 1. It's kind of verbose. Destructuring allows us to take that and put it directly into an array. So I can do what we see here. The x and the y inside the array brackets right there is in that const. We can do the same thing with an object. Note the curly braces versus the square brackets. Same setup, except this time we have to denote the variable names x and y and give them a value instead of just returning the value, because we're going to reference those. In the line where we're calling it in ES6, you can see that I've got an x and I've got a y colon my y. Both ways work to access what you're pulling out of there. So if you want to have the variable and you name it to whatever you want, then you put colon and then you put your own name in there. So it's saying x is or x as something else. So that's how you get through that. Named parameters. The options object paradigm allows us to pass in a set of named things into a JavaScript object or function. And so you pass in these, or it's expecting the options.start to be set to start, and then you can have it set to that or, just like we did before. So the defaults, each of those, and they're named. And then so if I want to just, when I run the select entries, and I only want to set the step, but I want to leave the others, then I can use this. That works. We can clean that up quite a bit, though. By putting it inside the braces, which is an object, then we can specify the names in there directly and the default values like we did before. And then we can access it here. So we don't have to do with the whole options reassignment thing. It's a bit cleaner. All right. In Java, we had arguments, like args in main. there's a similar idea here, but it's a lot less obvious. In JavaScript, okay, so there's another point to this. I'm guessing everybody understands this, but I just want to be clear. There is no concept of a signature in JavaScript. It's very key and important in Java to have the signature. You know, it's got a type, and it's got the number of arguments and what those arguments are, and so you can overload, and you can override, and you can get into all of that stuff. You can't do any of that in JavaScript. And then they've got this hidden variable that if you didn't know it was there, you might not even see it unless you started digging into somebody's code who's using it, called the arguments variable. And it's a limited form of array. It doesn't have all the array functions. You can get the index out of it, and you can cycle through it like an array, but it's not a full-fledged array. And you can see we're using it here as we're getting the length on it, and then cycling through with a for loop, and we can pull those out. What the arguments does is it allows you to take n number of variables into a function. So you don't have to specify what they are in the beginning. You just takes how many ever the person wants to put in. And so in this case, this function says I'm going to print out every one that they send me. And here I send in 1, 2, 3, so it prints out 1, 2, 3. All right. The rest operator, and it goes off of the idea of this, take the rest of the stuff, is those 3 dots, and then we name it. It can be any name. It doesn't have to be args. It could be foo. It could be number. It could be a or z. It doesn't really matter. But then you can cycle through that, and here I'm using the for of since it's cleaner and easier to go for each arg out of args, and then I can print those to the console. Cleaner. Now, what happens if you want to take, I know there's one thing that I want, in this case pattern, and then I want to leave the user the ability to put in other things. Well, in ES5 and before, this is how we would do it. We'd go through, and you have to do this sort of hack where you're slicing off the first thing, and you take everything else after that. So depending on the number of defined parameters that you want, and then the arguments is still on the end. So every function has arguments on the end if anybody ever wants to put it in there. So the user could send in as many things as they want. And it either works or it doesn't when it runs, but it'll compile. It just doesn't work when you use it. So we simplify that with calling out pattern here, and then comma, and then we use the same rest, 3 dots, and then whatever name we want to give it. And then you can access it the same way on the inside. So spread is just like rest. We'll get into how it works in a second, but this is the old way of doing it in JavaScript. And so I've got an array of temperatures, and let's say I had a function called myMax, which would return to me the max value of any set of numbers that I passed into it. But when I wrote it, I didn't write it, or maybe you wrote it, and you didn't write it to take an array, and I have an array. And what I'm getting back is an array, and I need to deal with that. So in order to do that, I use the apply, and then the braces. And the whole thing just doesn't make sense when you look at it the first time. You're like, oh, what is that doing? OK, yeah, I believe you. Let's test it, and we'll see. Yeah, I guess that works. OK, sure. But this is how we do it. But now, we just use the spread operator. Spread and rest are the same 3 dots. It just depends on what you're giving it. So if you give the 3 dots an array, it turns it into a set of values. If you give it a set of values, it turns it into an array. It just converts it from one side to the other. So in this case, I'm passing in the array temperatures, and I want to turn those into just those individual values. So that's called spread. So I'm spreading the array out and just leaving it out there. Now, when we're doing array concatenation, and you can use actual concat, but here you can see we're combining 2 with the push and apply. And then, but I can use the spread operator to convert those into values and just push them in and apply it that way. Right, so is everybody still awake? OK, let's make it sure. Yes?
That spread operator, does it only work in parameter code, in function code? Or can you use it in an expression, in a generate expression?
I've only ever seen it used in the parameters.
Exactly. That's where it makes sense. But
I don't know. I haven't tried it in any place else. I don't know. Just have to play with that one. I've not tried to convert things that way before.
I'm away.
Okay, good. In JavaScript, one of the most difficult things to grasp when you first start using JavaScript is how it works with inheritance. And JavaScript is object-oriented. For anybody who didn't know that, it is actually object-oriented, but it's not the way Java is. Java is class-based inheritance. JavaScript is prototypical or prototype inheritance. And so it works a little bit different. When we look at this, there's some things happening that aren't intuitive or obvious the first time you look at it. So the event. It's got two variables that get passed in, and they get set to the this in there. Well, this is a constructor. If you're writing it in most other languages, you would actually have a constructor that you could fill in and do that, because you're passing in variables and then you're setting them automatically when you create the event. Now, if you want to add a method to the event, you can't put it in event. You actually have to do it through the prototype syntax. And so you can see here, event prototype, and we're going to add the get description, and then you can put the whole description on there, which is basically a toString for the values that are in there. In ES6, they added some syntax sugar to make it a little easier to read and use. It doesn't change that it's prototypal. It's still a prototype underneath. This just kind of wraps it all up and makes it easier to read, make more sense. So you actually have a constructor, and that's a keyword, and then you can have methods as well, and they get added in like this. So it's a lot simpler to work with. Note that this is a class, and we're using that keyword, and there is no parentheses, or no, sorry, there's no comma or semicolons to separate the methods that are in here. All right. Under the old school inheritance and the way it worked with prototypes, when you are doing something in, you want to inherit from a parent class. So here we have an employee that's going to have a person that it's related to. So the person has the name, and you want to add a title to that. So then you create an employee, and you can add the title, but you got to call the person, and then you got to go through this machination here with the prototypes. You're creating the prototype person object and applying it, and you got to create the constructor for it, and then you can add the describe and work through this. This is how JavaScript works. This is, if you do anything in ES5 or before and you want to do any type of inheritance, this is how all of it works. But with the advent of ES6, not only do we have class, but we have extend. So we can extend the person, and then we can access it with the keyword super and pull it in, and simpler, easier. Now, one of the things that was always difficult with this pre-ES6 way of doing prototypes and inheritances is that when you have a JavaScript-made thing like error, not something that I made person, and then I made employee, but error is a built-in. Well, you got to go through this sort of hack in order to create your own version of an error that's inheriting from error or extending error. It's just, you got to go through and you got to create one and then set it and reference it. And I've got the method in there, and you got to use the error apply and null. It works, but it's hard to follow and hard to track. But now we can do the same thing, just extend error, and you've got it. And so that cleans that up a lot nicer. All right, the module system that we have now, we've been trying to do something in modules for a while now. I get ahead of myself. In Java, the idea of importing is almost second nature. And if you've jumped into anybody else's advanced code that you've seen JavaScript now, you've got a bunch of JavaScript files that are spread all over the place. I don't know how all this stuff works. JavaScript, when it comes down to it, is only one single file. Everything that is written in the JavaScript that goes into that browser page is in one file. It all gets pushed into that. Or you're going to have separate imports via the script tags. That's about the only way to separate it out. So in order to kind of gain some modularity in it, the revealing pattern, which came out a while ago, doesn't add anything to the code base or to JavaScript itself, and just wraps it in a module. It wraps it in a function, and you can put your functions inside of there, and then you just return them doing things, so like we have here. In order to kind of clean that up, we've got AMD, which defines it, and then you can declare your function that way, so it's the same thing on the inside. And then this has become more common JS. You see this everywhere using require. This is built into Node, so if you do any Node programming, this is how you're going to do the imports typically. And then you've got the module export to send the things out that you want modularized. With ES6, they actually have an import from, and then you've got the export at the bottom. And so it's a lot cleaner even than the last ones. There's one downside to this. Of everything that I've shown you, and all the other things that I haven't talked about in ES6, it's all been implemented in the latest browsers, past several versions of browsers. This hasn't. The module system has yet to be implemented in any browser yet. The transpilers can handle it, and if you use any of the build systems, whether it's Webpack or Require.js or whatever you're using, they can handle it. You want to use Babel or Tracer to get into it, they can handle that. Actually, let me go reference that. Just last slide, but this, you get links to Babel and Tracer and other things. So if you want to go through and add those things, the module system, then you need to use something that's going to transpile it and do it for you. So, questions?
In the class definition, you didn't use the function keyword.
In the class definition, I didn't use the key definition, the function definition. All right, let me go back to that.
Right? You get description for example.
No. And that's one of the key differences in here. So in ES5 and before, you have to use function because it's outside of the scope of anything else. And then when it's inside of a class, you're creating a method. And they've distinguished it, calling this a method because it is a function, but it's inside of a class. And so you declare it a little bit differently. And so you just use the parentheses, and you've declared it. So yeah.
Can you declare variables?
Oh yeah.
In the class?
In the class, you declare variables. Yep. Const and let and so forth. Yes. Var if you want.
Name and location in this case, right?
Yeah.
What about? Did you mean fields or variables?
Yeah, field. Yeah, field.
Fields inside the class. Is there a question?
Yeah, one question. Most of the people that I've seen using TypeScript before even ECMAScript 6 came out, and most of the things, not most of the class concept, import, all that stuff is already there. But I asked myself, what about type checks? So that is still something that is missing here. I'm coming from Java, so I'm used to that.
Right, so let me repeat your question for the recording. So you see a lot of things that are similar between ES6 and TypeScript, except the missing types. Well, that's what sets it apart. That TypeScript has those types, and yeah, they do all of the ES6 functions and advances. They have just about all of that in there. And they put in a few extra things too. So if you want to use types, then by all means use TypeScript. But there are aspects of JavaScript that you don't want to have the typings in. So people that want to have the strong typed language, then you use it.
Strings and numbers.
And JavaScript has the concept of, it knows that something is a type based on what it is once you declare it, but it's not a typed system the way TypeScript or Java is. I'm using TypeScript now, but it's an intentional choice to use it because the team that I'm working with, I wanted to leverage the typing to make the code more robust for them, and they were new to JavaScript and TypeScript, so I just picked that instead. But when you start getting into things that are functional, I think the variability of let not being defined has some advantages. So it depends on what you're trying to do and the mentality you have and what you're comfortable with, and I don't expect them to add types to JavaScript anytime soon. So it's a good question, though. Next question? Yeah?
Have you seen any polyfills for extend?
Polyfills for extend. Core.js, maybe?
Core.js.
Maybe. I haven't looked for it, but I would guess Core.js is the first place I'd look.
So I have a question. Maybe you covered it a little bit.
That's right.
Did they address the concept of like null and undefined? I found that really.
Yeah, so in JavaScript, the question is, have they addressed null and undefined? In JavaScript, in some of these newer things, they're dealing with it a little better, but for the most part, no. It's still as crazy and weird as it was before. So here's an example. In ES7, there was only two things that were added. I didn't bring it up because they're so minor from my point of view. One is the includes in an array. So now in ES7 you'll be able to do includes, and the difference between that and how you would check it normally is that if you just are looking for X in the array, it would look for it and tell you if it finds it. But if X happens to be a nan, it wouldn't find it. But if you're using the new includes, they've actually structured it so that if you're looking for a nan, it'll say, yep, I found the nan, it's in there. And so they're working at getting better at it, but they can't break the existing stuff because then they'd break the internet. But if that's really important, then maybe you should look at TypeScript because they do handle null and undefined as types.
I'm simply asking because this looks like an improvement.
I think so.
And when I do have to use JavaScript, I always get annoyed when I find things are undefined and things are null and we have to differentiate between the two.
Yeah, I understand that. What other questions? Yeah, go ahead.
So when is the implementation of import going to be put into the browser?
I do not know when import is going to be brought into the browser. We're all waiting for it. But the build systems that we're using right now handle it without a problem. I'm seeing a lot of people go to Webpack, and Webpack handles it really nicely. And whether you're using Grunt or Browserify or Gulp or whatever, what have you, and the transpilers as well. So you can deal with it with the transpilers. Anything else? well, thanks, guys.